Hello. We'll wait for a little bit more for for the rest to join. Welcome everyone to the workshop. Uh, I'm Siang, uh, and we are joined by my colleagues and our CTO, I think, today. So hello everyone.
Yeah. Hi, everyone. Want to start now or wait a little bit more?
Mm,
Think just give another 2 minutes
yeah,
before you start.
sure. My colleagues and our CTO, I think. So just hello. I guess we'll wait for another minute before we start.
Yeah.
So how do you guys know about the event? Mm-hmm. Oh, which group do you see it from?
I think Fatur post to Facebook.
Yeah, I think yeah.
I just forgot to post it on Twitter and LinkedIn.
I see. I should join that group sometime.
So I guess we can start now. 5:35.
All right.
Okay.
Okay.
So welcome to the Laloka Labs workshop, everyone. I think this is our third workshop, I think, and will be so. Previously, we have on Django, and then we have workshop on Tailwind CSS by Factor, and then this is will be the third one on Rust, and also the first for 2022. So we plan to have this workshop at least every month. And we'll cover various topics that we found maybe of interest to the community. So today we have Xiang will be sharing about Rust programming language. So if you guys have questions, feel free to ask either directly. Just ask. You don't have to wait until the session end, right? Or you can ask through the chat. So not wasting the time, I think give this to Xiang. Can start now.
All right, thanks.
Oh, sorry.
Mhm.
Before we start, I just want to mention that we will be recording these sessions.
All right.
Okay, okay, all to you.
Okay, thanks. Mhm. Just a very quick introduction. My name is Xiang. Um, I'm a software engineer. Working on Get OTP in Laloka Labs, and I program mostly in higher level, and dynamic language, which is Python. But I do like functional programming. So today we are covering in this is a 1 hour workshop, so we'll be covering basic introduction to language syntax, and then we'll test out some ideas through Rust Playground, and then some of the examples that I'm going to show is going to happen on Rust Playground itself, and then if we have time left, I'll attempt to show you how you can learn by solving code katas and exorcism. So let's get started. So a lot of the demo today will be done through this interpreter. This is a personal project by a Google engineer, and it's called eFixer. All right, so this is a
Uh,
very yes.
can you enlarge a bit the font? Thanks.
Is this large enough for everyone?
A little bit more.
All right.
Okay. Okay,
Okay.
that's good.
This is a very basic interpreter. It does not do everything the language offers, but it is good enough for the demo purpose today. So usually when we learn programming language, we start by doing some sort of assignment, assigning some values to variables. Um, so it is done very similarly in Rust. If you are coming from JavaScript, it uses a syntax like this. Let keyword followed by an identifier and then some value. However, unlike normal programming language that you see out there, you cannot change the value or manipulate whatever that's inside there directly. Like you cannot do so you will be getting an error saying you cannot assign a value to the variable twice. So it also suggests you to consider making this binding mutable. So what you need to do is that if you intend to change the value, you need to add a keyword, mute, which stands for mutable, followed by an identifier. Then you can change the value. Sorry, you can do this. So be you may be curious, like how is it different from constant? Because in Rust you can do this too. You can define a constant by doing and then you need to always specify the type. So you may find this and this sort of have the same meaning. However, a very quick differentiation between these two is that one is evaluated when it is the code is being compiled, and one happens when the code is one is runtime and one is compile time. Let variable declaration is compile, runtime, and then this is compile time. Later you will see if you declare a variable, you will see why it is not the same as constant later in this session. So just keep in mind that if you intend to change your value of the thing that you assign to, you need to add a you need to specify the mutable keyword inside the binding. All right. So like a lot of modern popular languages, Rust is not dynamic. It's statically typed. However, you can see that I didn't specify a data type here because it can do some very basic inference on the type of what you actually intend. So if you, for some other trickier data type, or if you want to be explicit, you can actually do it. So for integers, you can do maybe x2, and you can have so if you do not specify the data type of an integer, by default, if I remember correctly, it will be by default it will be a 32-bit integer. And then we also have floating point numbers, for example 64, which happens to be the default, if I remember correctly, because a lot of things change throughout the years. All right. Then we also have Booleans. We have newcomer. Hello. We also have Booleans, and we have true, false, and then we also have string, like I shown just now. We also have characters. So with all this, you can do some sort of mathematical operations, like so, that y equal to m plus times x as f64. You need to cast everything into the same data type, plus c f64. All right. So you have a value in floating point. All right. Now we talk about strings. String is a very special type of data type. So just like I showed you, fixed size string, let's say we have, don't change me. So let's say I want to append things after the string. So usually in other programming language, all you need to do is that you do fixed size string, you have some concatenation operator or whatever. In Rust, you have something like push string. However, you'll find that even though this looks right, but this is not actually defined for string. So if you really want to manipulate a string, like you want to append things to it, you actually need to define your string differently into another data type. So it has to be a string then you can push things to it. Manipulatable string will then become this. The reason being, a very quick reason behind this is because if you declare it as a normal string like this, it's a fixed size string that Rust will attempt to allocate it in the stack. So it's not exactly allocate in the stack. It's just that it has a pointer to the heap, but it always takes the same amount of space in the stack, so that yeah. And unlike this one, because this is a dynamic one, so it stores a lot more than just the position in the heap. So so they are not actually interchangeable. So they are different, and they have different API also, which is why even though they look about the same, but this method is not defined for this kind of string, but this method is defined for the other type of string.
But you can still change the value, right? As long as it's the same size.
Yes, you can still change the value, but as I said, these two data types are different. So if you want to change, you need to change it with something in the same data type. So for example, fixed size, you cannot do this because the type is different. One is just a pointer, and then another is um a new type. They're different. The same can be said for vectors and list. So in other languages, you have lists or arrays that looks something like this. 1, 2, 3, 4. Let's make it mutable. Then you also have let mute names. Let's say Peter, Jane, and if you attempt to push new things into it, push 5, let's say, you will find that this is not defined for array because they are not meant to be manipulated this way. So what if you really want to have something that you can manipulate, like you can push value to it? You want something that you can keep pushing values to it. You can add or take off a value. What you do is you create something called a vector. New numbers. Whenever you see exclamation mark, it means this is a macro. So we will construct a vector by using this macro. Oops. Did I make new numbers? I must have done. Yep. Okay. Yep. So if you want to attempt push, then you see a new member is being pushed to the vector. As mentioned, Rust is a statically typed language, so everything inside the vector or an array or even an array must follow the same data type. So, right. Is there any questions so far? Donaldson asked about if Rust has an interpreter shell. Yes, Rust has two actively maintained interpreter shell. Not really REPL, but they are good enough for quick demonstration or quick calculation. The one that I'm using right now is called Avixer. It's done by a Google engineer. So you can find it on GitHub by looking for this Google/Avixer. And there's another one called iRust. I don't remember the actual path to the project. Yeah, but I prefer the output of this one better for this demo purpose. So I'm using this one. All right. You may see me doing a lot of assigning the same thing to the same name. Like you can have let mute bar let mute one. It's possible, and we call this shadowing. It's useful when you need to reuse the same name but for different purposes. So for example, okay, now that I have full is one, then somehow in the middle of calculation, I need to reuse the name full for other purpose. So what you can do is that, sorry, I see another problem. I'll answer your question later. So back to this. So if I want to reuse the same name for other purpose, what you can do is that you introduce a block scope. Then you can let full equals to maybe a string. And then if you attempt to print it, it will return a string instead of a number. But when it's outside the scope, if you do a check again, it will be back to number. It will be reverted to the previous value. I think Donaldson, you missed the when I talk about macro. Yes. Whenever you see a macro, whenever you see an exclamation it means there's a macro that's involved. So now we have seen two types of macro. One is to construct vector, and then another is to print things. And then later you will see a couple more, I think. All right. Whether if it's like C macro, I do not have experience using C macro, so I cannot answer you on that one. Yep. And also for your information, I will not cover macro today. Yeah, but there's a chapter on macro in the Rust official guide, so you can go have a refer after this. And I highly recommend everyone to go back to the Rust official guidebook for more information as a starting point to learn the language, because it's very well written, and even though it's a couple of years old, it's still very relevant to the current version. All right. We just covered shadowing, where you can reuse the same name for other purposes. Then we also have Rust also allow you to define things like a range of values. For example, if you want to define a range from 1 to 100, you can do this. 1 to 100. I think this exists in other languages also, but this is the Rust version. If you do not want to include 100, you just do this. All right. So now I think I covered most of the basic ones, basic data type, and then basic ways to define for you to represent information. So we'll go to branching. Before we go to branching, if statement, match statements, any questions? No, then we'll move on to writing an if statement for branching. If statement is also similar to other languages. It's just if a condition, then you do things. This is also another macro. So it takes two arguments. One is the format string. It's very similar to the one that you see in Python. And then the value to be replaced into the placeholder. You can add more clauses to this by using else if. And in Rust, there are two different words. All right. Then we also have, lastly, if you need it, you can write a else clause. And there's one thing to note that in Rust, whenever you see braces, you can actually have it to return a value. So if you want to return a value, in this case in if statement, so you will have to have both you will make sure, you will have to make sure all the possible branches returns a value. So how you do it is by writing the last expression without a semicolon. It has to be an expression that returns a value. So for instance, it can be then we return a value. So what this enables is that you can do this. Let if then full will be equal to 100. It is applicable to most of this braces pairs. So it can happen in if statement, it can happen in the block scope that I shown you just now. So you can have that full equal to a block scope. Let's say you have some other temporary calculation. Then you can do something like this. And then if you leave out the semicolon, the value will be returned. Oops. Did I? Yeah. The value, the last expression will be written as a value, and then it will be assigned to full. So full will be 400 in this case. All right. So you can have other statements inside the scope, the block, as long as you end the last line, last expression, you end with an expression towards the end. And if you have if and else, you have to make sure it always returns. So that means you always have an else clause in the if statement. All right. Then besides using if for branching, there's also a rather powerful matching statement called match. Okay, match. Let's say I'll match let's say true. What's the syntax? Even. Then false or yeah. So you can see a match statement is doing some sort of pattern matching if you are familiar with Haskell. So it will match the result, the condition, and then it will give you the respective result. But you can also expand this to have multiple statements by putting everything inside braces. Let and then because the first one, the first arm returns an integer, so the other one must also return an integer also. All right, and if you are familiar with Haskell, if you do not specify all the possible matches, Rust will complain because it's not exhaustive. All right, of course you can there's also, it's possible to match multiple conditions also. So for example, all right, then you match, this is tuple, true, true, outcome A, then true, false, outcome B, false, true, outcome C, false, false, outcome D. It needs to be exhaustive. So if you somehow forget this one line, Rust will complain, the compiler will complain because one of our pattern is not defined. And you can also put a wildcard to cover the else part of the matching. See, all right. So these are the two main ways to do branching. One is through if statement, and one is through match statement. So you can do some sort of decision with these two. And then we have we move on to looping. Looping or repeating similar things or similar tasks is through, there are two main ones also. One is through a loop statement. Oops. Okay, so like it works sort of like a while through loop in other languages. So let's have a counter. Then you can loop. If counter is 99, for example, you break the loop. Then you print out the counter or do other things with the counter, and then you increment the counter. Counter plus 1. Then it will loop through like normally that you expected in as in other languages. And if you remember, I also introduced the range, a way to declare a range of numbers. So let's say I have for I in 1 to 100 I. It achieves almost the same thing. It also prints out everything from 1 to 100. So this is how it looks like. It's very similar to other languages as well. So I suppose everyone is familiar with this syntax. All right. So now that we know how to do branching, we know how to loop, we know how, we know how to do repetition, and then next we will explore how to define a function for reuse purpose. So we can to declare a function, we start by a keyword fn. Then we continue with a name at 1, for example. Then we define the arguments. In this case, I, we take an integer. Then we need to declare the return type. So in this case, I'm returning integer also. So as I said, you can actually just leave it like this. Leave the last expression as the return, and it will work. However, if you prefer to be more explicit, you can prepend it with a return. Make it a statement. All right. So there's also a way, if you are more a functional person, you can also define anonymous function. But I won't be demonstrating it directly here. I will show you in one of the next examples. So now that we know how to do branching, we know how to do repetition, we know how to declare functions for reuse. So we can attempt to solve some very well-known programming puzzles, and then hopefully I will show you how basic Rust programs looks like. So for instance, I am sure a lot of you heard of FitzBus, where given 100 numbers in turn. So if a number is divisible by 3, you shout fizz. If it's divisible by 5, you shout buzz. If it's divisible by both these numbers, you shout FitzBus. It's a very well-known programming puzzle. So in Rust, the most basic form looks like this. So you have for I in 1 to 100. This is a loop. Then we followed by I. Whispers. Else if I 5 is I else. So we are printing the number, because the first one is always a string template, so it has to be this way. Close the loop. So there you have it, a very basic form of demo program where you see a loop, you see branching. All right. Of course, using if is one way. You can also use a match statement, like I shown just now. So it would be very similar. So instead of this, we can make use of match I 3 0 I divisible by 5. So I true. So if both of these are true, then we print this bus. True, false. This false, true. Lastly, the number. Yeah, it will work similarly. I forgot. Yep. All right. So these are the two very basic way to write a solution for this puzzle. But if you are more a functional programming kind of guy, and I'm about to show you how to write anonymous function. Just how we saw a function is defined with a function fn keyword, right? So in this case, in order to write fizzbuzz in a more functional manner, so you can have something like this. We start by a list, a range of numbers, and then you can map over it. So the way anonymous function is written is by, you start by declaring the arguments inside two vertical bars. In this case, I. The data type is optional, and the return type is also optional. So you can have match I, like we did just now, I divisible by 3, check, oops, and also I divisible by 5, check. Then the rest will be the same. True, true, face plus, true, false, false, true, catch all, close of this, close, close. Oh no, not supposed to print. I'm supposed to format. I'm supposed to return a string. And then once we have the result for each of them, we print the result. So it's rather similar. It's just that if you are more familiar with functional programming, you will see some familiar construct like you have map. You also have for each, and of course you can just do everything inside the for each here because the end product is, but it's just printing out the value to the screen. So it allows you to do some sort of functional programming uh, through the syntax, the language construct. Next, I want to talk about borrowing. Then this is when I move to the Playground. Rust Playground is located at play.rust-lang.org. So if you're interested, you can go have a play with the language syntaxes and do some experiments later. So these are the functions that I will be referring later. So let's paste it down here. So I want to talk about borrowing. Um, being uh, Rust is always referred to a language that is safe. So a lot of it is um, owing to the concept of borrowing. So to demonstrate that, uh, let's declare a variable borrowable. So let's print. So you will see the value it's being printed here. So if I assign the value to something else, let's say if I do this in other languages, it will work fine. However, in Rust, if I attempt to print the value of borrowable, I will have an error because in Rust there's a concept of ownership. So in this case, whatever that is assigned to borrowable is being moved to the new name stolen. So which is why you see an error here. Use of moved value borrowable. So if you print stolen instead, you will see stolen takes over borrowable and represents this object here, string object here. So, however, like if you have this concept of ownership, how are you going to do any sort of computation by sharing data across functions, across variables? What you can do here is that through the concept of borrowing. So you can borrow the value by using reference. So you can have that. You add ampersand in front of things that are borrowable. So in this case, if you attempt to reuse to print out the value of borrowable, like we did just now, the value will still be printed, and then borrow, like it can do whatever he wants with the value. So all right. Borrow can print the value, can generate a new thing by referring to borrowable. Yeah, it's all made kind of possible. You can see both mm, they have access to the value somehow. It's not really access to the value. It's just through the reference of the uh, it's through a reference. So a read-only reference like this, it can have multiple ones. So you can have a lot of things referring to the same thing. It will work. It will still work. You see all of them will have a reference to the original item. However, just now we know that you can manipulate the value by introducing the mutable keyword. So if you attempt to borrow this value to multiple places, let's say I want to have borrower by the way, you do it by doing this reference plus a mute keyword, and then you lend out the mutable reference to another variable. So let's do another one. Up until now, everything seems to work. Alright, everything seems to work. There's no error. You just have warnings of things not being used. However, if you start doing the manipulation, push, the moment you start doing push string, the moment you start performing manipulation, you start getting errors. You will start seeing things like cannot borrow borrowable as mutable more than once at a time. In this case, we are borrowing it. We're lending the value out twice. The borrow happens twice, and then we are attempting to manipulate the item, that object, by calling a push stir. This is when it raises the error. Because at any one given point, only one there must be only one mutable reference. So if let's say I deleted one of the borrower, then everything will work as it should. Yep, it will work as it should. Borrower still owns the original item, but whoever who borrows it with the mutable with a mutable reference will have the ability to change to manipulate the value. So one main principle that you need to remember is that at any given time, there must be only one, at most only one mutable reference around. You cannot have more than that. This ensures no multiple mutable reference, so you cannot have race conditions or things like that happening. So if we expand this, just now I demonstrated how borrowing and moving in terms of defining variables, but it can also happen when you call functions. So for example, let's try to print borrowable again, and then this time let's say we call this. You will see another move value error. So what happens here is t function is this. So t function takes an argument that is of string, which is satisfied here. It's the same data type. And then it uses the value inside it. And then after the function exits, this borrowable is dropped. It's not being returned back because the ownership changed from here and then it moved into the function and it is not being returned back. So this is exactly what happens here. So when I attempt to print out the value of borrowable, because it's being moved into the function, so I'm getting an error here. I cannot use it anymore, even though the function already done its execution, because the value is moved into the function and it's not being returned back. So this is the concept of moving. Next we will see. Just how I showed you how it is possible to borrow. Right? I showed you this just now. So if you do it in terms of function, it's the same. You can declare a function that takes a reference of whatever that you want to pass inside, and it will not take the ownership of the item that you passed in. So in this case, it's only borrowing the value. I must have, yeah, sorry. Yeah, it only borrows a reference of the thing that you pass in. Or you also need to do it here. It takes a reference of the things that you pass in, and then it will not take ownership. Once it's done using it, this is dropped, and this still holds the original object. It's practically the same as this. Oops. It's the same as this that I showed just now. And then we also have mutable reference, which looks like this just now for rollable. So if you want to pass the value, the mutable reference to a function for other operations, it looks like this, right? You pass in the mutable reference of the thing. It will do, this is from here. We first manipulate the mutable reference. We print out the value here. Then when we exit this function, this argument is dropped, and then this still holds the original item here. And so when you print out the value of the variable, it's still containing the copy, the original copy of the item. So it still holds ownership. The ownership is not moved into the function like this function here, because it's only passing a mutable reference into the function. So this will still work. So what if you sometimes you really want the object being passed in instead of a reference? It's one way to do it is by doing this. You take in the item, you manipulate it if you want to, and then you return it back to when you exit the function. Then you capture the value, the return value back, and then you will still have your object. So the ownership is being moved from here when you declare it, and then you move it to the function. When the function exits, it returns it back to where it is being called, and then gets assigned to the variable here. So when you attempt to print it, it still holds the ownership of the item. Yeah, I think it's a bit abstract, isn't it? Yeah, but that's the very basic concept of ownership and then the borrowing system in Rust. So you may find this a bit hard to understand. However, this only happens for type that we call this kind of object non-copy type, where there's no way to know how much space to allocate for this kind of data. So if let's say all this, we do the same thing, like we assign it to a number, a scalar. We call that a scalar, a number, or the fixed string, where the size is known. Then we do not have all this borrowing ownership problem, because the size is known, and then we always know how much space to allocate. So what the compiler do is it will just copy everything around. So there's no more concept borrowable. Like just now we were having problem like we cannot have multiple. Let's say this is number. We cannot have mute borrowable. Let another borrower mute borrowable. This will not happen because what happens here is when needed, the compiler will just copy everything to everyone who ever needs it. Because scalars are all known size, and then the compiler always know how much space to allocate, and they usually are not that big. So all these are not necessary anymore. It will just work. Probably did something stupid here. Yeah. Because it's a reference, so I need, yeah, probably need to do some referencing magic thing. Yeah, but you get the idea. So scalar data type it covers like plain string. We have numbers, booleans, floating point numbers. Yeah, basically these are all it, and then the arrays. These are all scalar where copying is very cheap relatively. But however, if you really don't mind efficiency, usually non-copy type they implement something like they implement a method called clone. So this would not work just now. Or we don't need this to be mutable. This will not work just now because thief takes over the ownership of the argument passed in. Why are you so slow? So if you remember, this will end up with an error because borrowable is the value of borrowable is moved into the thief function here. However, if you really want to do it this way and you don't mind efficiency problem, you can just clone it. Let thief has his own copy of borrowable, and then borrowable still keeps the ownership of this. Yeah. If you exactly as I said, value is being moved to a function, so you cannot use borrowable anymore. But if you clone a copy of this into the function, it will work. Yep. You get the printing here, and then you get to own the value inside the function. also. It will still work. Yep. Practically, yep, this is all I wanted to cover for today. And then I think I'm running slightly over time. So a very quick mention on exorcism. Exorcism is a place where you can practice code, programming code katas. And there's a Rust track in exorcism where you can do puzzles in Rust. So recently they upgraded the system where you can do the exercise directly inside through the website and then have all the tests done through the website also. So for instance, I think this is 40. You can write your implementation inside the stub code and then step by step by following the instruction you can complete the exercise. And you can see the unit tests, how you fail, how you pass. And then once you are ready, you can apply for mentorship where people can give you some feedback on your submitted solution. Let me see if I can show you an example. Or see all of my iterations. Yeah, you will get to talk to your mentor on what can be improved and then the mentor usually will give you some hints or guides on how to improve your solution. Yeah, practically this is it. That's what I really wanted to share for today. So as I mentioned just now, the interpreter that I use is called Evixer. And then if you want to experiment with the language, there's a Rust playground, and the exorcism is the place where you can do programming exercises. Rustbook is the official guide for the language, and if you are into learning the language through uh, live streams, you can follow these two YouTubers. They cover a lot of in-depth topics of the language periodically. So that's it from me. Any questions? If not, we can close the workshop for today. Or if you have more questions, you can stay around and we can talk.
Thank you, Jeff. But I have fogging impression in my area right now. I can't turn on my mic.
Okay. Anyone has any question? If not, we can stop the recording, and then if you want to ask question outside of the recording, you can do so. All right. I will